Okay, hello guys, welcome back to my channel. And today I'm gonna make a palm oil and biodiesel presentation. But actually, I'm using Indonesian language in this presentation. This is not really well for you if you are using English. Okay, but you can still listen to me and see the references as if you are really learning about this. You can just see the references. Okay, so what is the benefits of biodiesel? Biodiesel is very good to fulfill our energy crisis. Yeah, energy crisis comes up, and we need renewable energy that comes from palm oil to form biodiesel, but biodiesel cannot replace the diesel a lot because it's only like 5 to 30% of biodiesels plus 70% diesels, fossil diesel could fit the engine because the 100% biodiesels for our engine is not really well. Pure biodiesel is not really well because it's really high viscosity, it's very dense and it could be looks like frozen in your engine, and it could also dilute any plastic material in your engine joint because they need like plastic. uh, yeah, it will breaks your engine or sort of. And then it's wahid. uh, we choose palm oil to make a biodiesel because its oil yield is high. So yeah, we could bring up a lot of oil from palm oil. And yeah, diesel is firstly well known uh, by inventor. I think I don't know, it's Rudolf Diesel, as you can see here. Yeah, just that. And then the 90s 70s, yeah, there is energy crisis. And I don't think this is really important. Yeah, in this biodiesel industry, yeah, it comes up again after the diesel because diesel is cheaper than biodiesel, but biodiesel is renewable. Yeah, the cheap diesel plus renewable biodiesel, yeah, it could fill each other so that we can take advantages. And biodiesel itself could be formed by waste, organic waste or other, biomass like plants, animals. It's a biomass. And industrial challenge, yeah, of biodiesel. Yeah, biodiesel needs plants. We need a lot of like lands, and it will destroy animals, bring animals to extinction. Global warming and biodiversity is, yeah, yeah, because of the extension is exists, biodiversity is getting lower. Biodiverse, biology and divergent. Yeah, many type of biology, it's biodiverse city. And yeah, the problem is that biodiesel is, yeah, much more it's a bit more expensive, yeah, than a diesel itself. It's open AI. I don't know, but actually you can find it anywhere. About the file, um, let's go next. The stick notes and Scudart 2011 LCA about its life cycle analysis, of the palm oil. 1 ton palm oil needs 5 tons of palm um, palm fruit. Yeah, so it's 1 to 5, and then 1 ton palm fruit could produce like a lot of carbon dioxide, like 110 to 460 kilogram of carbon dioxide. uh, you know, the palm oil production will makes a global warming, eutrophication, and toxicity for human because of the nitrogen oxide and I think there is a metal, yeah, because the heavy metal that is produced by the palm oil waste for production, and actually it could acidify our climates, yeah, because of the burnings of the exhaust gas, uh, from probably making the machine work. We need some engine, we need some energy. Okay, okay, the palm oil itself, we choose a palm name like Tenera. It's a crossing between Duta and Psifera. And in the future, you want to cross any type of palm, you might can do better than Tenera. Okay, the recovery is, yeah, we might have improved Tenera like to get like more than 20%, like 25%, or up to 30% maybe in future, or maybe right now some industries. We don't know what kind of industries, what is the name of industries that. And we have Malaysian government. Actually, Malaysian and government and Indonesian government sounds like really lovely to produce a lot of the palm oil. It's much bigger than I think US. And yeah, you need a lot of like weeding, and then in insecticides, and fertilizer, to make your own palm oil grown really well. Okay, how to make a biodiesel? It's a transesterification, but actually biodiesel is much better, is formed by the canola oil, because canola oil is a very good reactant, and has a low, it's hardly to get frozen. Canola oil has a low viscosity, so that it's very light, not dense, not sticky. Yeah, and this is the fame is the ester, yeah, fatty acid methyl ester, but the picture here is a bit wrong because it sounds like fatty acid ethyl ester, yeah. It's not methyl. Yeah, the organic compound that in this picture, it's actually fatty acid ethyl ester. But it's actually supposed to be fatty acid methyl ester. It is a bioethanol. The fame is bioethanol. So after you react the oil with the methanol with the catalyst and appropriate temperature and pressure, yeah, you can form a fatty acid, methyl ester, the bioethanol. So you need a alcohol. Methanol is usually used because it's cheap and very good. Or ethanol. Ethanol is also is the second most frequently used to produce the bioethanol. So technically, this one is right. The fame is right. Fatty acid methyl ester is right because it could be like fatty acid ethyl ester too, as a bioethanol. As you can see here, ethanol is used, and we use natrium hydroxide. It's sodium hydroxide because it's cheap also. And the methanol to oil ratio is 6:1 or 12:1, and the catalyst is it's 0.05%, or up, oh my god, it's 0.005 to 0.35%. compared to the the oil itself. The catalyst is 0.005% to 0.35% compared to the oil. And then the catalyst, if you don't like the catalyst, like the natrium hydroxide, the sodium hydroxide, you can use biocatalyst like lipase enzyme, or any any like potassium hydroxide, carbonate, etc. Or acid. You can also use acid. But if you use acid as your catalyst, you need 30 to 1 methanol to oil. So 30 to 1 is not well because we got 6 to 1 that is much better. So if you use acid catalyst, it's not really that well. And then the temperature is 20 to 35 Celsius. Pressure is 1 atm. Well, the higher temperature, like 45 Celsius to 60 Celsius, yeah, even though they are producing more oil, but 60 degrees Celsius is not really that well. And then the improvement is way too low. We don't need that small improvement compared to 60 degrees Celsius or 45 degrees Celsius. Um, it's actually also in the field, we also have a problem with the water content and the free fatty acid content that might ruin our machine, ruin the product itself. So yeah, in field we have a lot of problems to make a biodiesel. And then it's 15 minute for beef tallow. Beef tallow is kind of oil, but it's not palm oil. It's the residence time, in reactor. It's 15 minutes, but actually it's also, yeah, around 15 minutes for the others, I think, yeah, in reactor for that long for mixing the methanol and the methanol or ethanol with the oil. And diesel, number two diesel, yeah, it's the number two, can be mixed with the vegetable oil, like 20 to 80, 20% vegetable oil, 80% is this fossil diesel. But actually it was in the past, for the old diesel engine. So how about the modern diesel engine, modern cars for diesel? It's not really fit well, and you can't mix it with the vegetable oil again. And we can make the oil from the pyrolysis too, as if you need something, you are in it with the oil source, but you can't even afford it, but you have the organic waste. You can, pyrolysis is using heat, and it will broke the organic to the smaller carbons chains, so that the heat is free of oxygen. And yeah, we can cut the chance of, like, to the smaller chain, so that we could get the oil from the organic waste. And then after that, yeah, it will produce the oil. But actually, if you want to produce the oil, we can saponify it first, like this picture. It's a saponification. It's a oil plus base solution. It's a sodium hydroxide, and it's a saponification, so that we get a soap at the right side of the product and glycerol at the left side of the product. Um, Yeah, glycerol in Indonesia sounds like glycerol in English. The difference is on S and the C, glycerol, cerol. And yeah, after the saponification, you can use pyrolysis, and then after the pyrolysis, yeah, you can get the oil that you need for the methanol and sodium hydroxide reaction. Okay, guys, this is all. This is my references, and this is too. Okay, see you next time. Goodbye.